Okay, this is the lecture video for MAT 1100, lesson 2.5. And just as an outline of what we'll be doing in this section, we're going to be estimating numbers, sometimes for an application type problem where you will have a specific scenario that is described to you, such as what you see here in examples 1 and 2, and you will estimate based on the given instructions. Other times you're going to be estimating using graphs. So that can come in the form of a line graph or a bar graph or even a scatter plot where you'll be asked to estimate a particular value. We're also going to look at the skill of comparing two numbers. So given two numbers, are they equal to each other? Is one less than the other one? Is one greater than the other one? So I've listed a summary of the symbols for you right here, and you will use from this list whatever the symbols are that they mention in the instructions. Sometimes the instructions will not concern this entire list, but these symbols can pop up in various problems, and so I summarized them for you here. You may not have this in your lesson packet, and if you don't, because you haven't gotten the most recent packet, then you can just add that into your notes. Let's see what else. And then we're also going to be looking at some word phrases that are used very commonly, and you're going to be expected to translate them into these kind of symbols here: less than, greater than, etc. Okay, so let's get started. In the first example, we're being asked to estimate the difference of two numbers, and we're being asked to make that easier on ourselves. In other words, bring it down to a point where possibly you can just do it in your head by rounding first. Okay, so you're being asked to round each number to the nearest whole number. And so I pointed out to you which of the numbers here, which of the digits here is in the whole number position, and that would be this 1. So you're making a decision: should I keep this rounded off to 71 or should I push it to 72? When you round to the nearest whole number, you should not be reporting any of these numbers after the decimal. So you look at that 2, that says keep this as a 1 rather than rounding it up. So this number rounds to 71. Then we're doing a difference, and we're also going to round the other number. So once again, you're looking at the digit in the whole number position. That would be that 7. And you are asking yourself, should I keep this as a 7 or should I round it up? Again, you're never rounding down. Look at the number next to it. Since this is 5 or greater, you're going to round this up to 68. Do away with those numbers after the decimal. That's what it means to round to the nearest whole number. Get rid of the numbers after the decimal. So that, because you no longer have the decimal portion, it's easy to just do that in your head. The difference between 68 and 71 is 3. If you feel you still need to put it in your calculator, then do so. Okay, here we are estimating 15% tip on a dinner bill of $63.43. So another application type scenario. They're trying to make the problem or the calculation, the estimate easier by you first rounding the amount to the nearest $10. So you want to go to the number that's in the tens position, which is this number right here. And this side is this number. Is that number right there closer to 60 or is it closer to 70? So you're rounding to the nearest tens. Okay, so that is closer because of this number right next to the digit that's in the tens position. Since this is not 5 or greater, that means you're going to keep it at 60. So we want to know what is 15% of $60 after rounding that off. Okay, remember that this means 15%, but in decimal form. Percentages are always used in decimal form when you're going to put them into the calculator. Of means multiply, and instead of using all the change, you're just doing 15% of 60. You could feasibly do that in your head, because when you're doing 10%, you just move the decimal over one place. So that would be 6.0. You move it one place over from where it is to take 10%. So some people do this in their head, especially when you're trying to figure out a tip on a bill. You might be wanting to do 20%, 10%, or even 15%. So 10%, you just move it over one place, and that would be $6. And then half of that, to give yourself another 5% on that percentage, would just be half of that $6, which is 3, which is equal to 9. So if you are not comfortable doing it in your head, once again, you can use your calculator. So just 15% of 60, if you are going to put it in your calculator, it would just be like this. And you would get, oops, I turned to put it in wrong, 15% of $60. And you get $9. So either way, you can do it either way. Again, if you are attempting to be able to do some of these in your head, because sometimes we just don't have a calculator or a phone with us to figure out the calculation. If you were going to do 10% rather than 15, you would slide the decimal over and get 6.0, which is $6. And then another 5% would be half of that, an additional $3 added to the 6, which would give you 9. Okay, in the next set of problems, we are comparing numbers. We're being asked to insert either a less than symbol, a greater than symbol, or an equal symbol, one of those three symbols. So let's see. 20 is less than 6. Remember, the pointy part always points to the smaller number. The big number sits inside the opening. Okay, when you come over here, 9 is the smaller number. Pointy part points right into that smaller number. Bigger number sits inside the open part. Okay, 83 is less than 354, and 538 is less than 734. So just comparing two numbers using the symbols that they've offered in the instructions. In the next set of problems, still concentrating on the concept of inequality, and you can put that here, that you have some inequality symbols. So you could label this symbols for comparing numbers. These in particular, anything to do with less than or greater than or any variation of that, these are called the inequality symbols. And this is just the symbol for approximation. When you want to say, for instance, 3.2 is approximately 3, you could say something like this. 3.2 is approximately equal to 3. If someone asked you to round it off, because when you round something off, you're approximating it. So this is what we call the approximation symbol. We want to use this symbol just any two numbers that are not equal. 5.1 is not equal to 5. It is different than this number, and therefore it is not equal. If they were equal, they'd be exactly alike. Okay, come down to these problems. I believe if you have one of the older packets, you have just C is less than or equal to 5, and I've added a couple of extra examples, and you can just write those right into your packet. So you have a verbal description here. You're going to insert one of these symbols as indicated by a specific phrase here. So this phrase is what we're concentrating on. Less than or equal to. So we're talking about this variation of the less than symbol right here. Less than or equal to. So C is less than or equal to 5. X is approximately 3.25. X is approximately 3.25. Okay, A. A is greater than or equal to. We're concentrating on this phrase right here, greater than or equal to. Here we were concentrating on approximately, and we're deciding what to use. So A is greater than or equal to. A greater than or equal to. And I think the number got cut off here. Why don't we just put a 2 there? Greater than or equal to 2. Got cut off by my text box. So just remember, when you're trying to figure out where to put the value that you are comparing to the other one, when they talk about this being greater than, the greater than number always sits in the open part. Whenever it is the lesser number, it's right here. The point will go right into the lesser number. So this is the greater than number. It sits in the open part. This is the lesser number, and it is on the other side of the point. Okay, just a few examples of how to apply these symbols when you are given a verbal description. Okay, going down to this table, is it a solution? So here is what you are plugging into. Anything that creates a true statement when you plug it in here, then that would be considered a solution. So a solution is when we create a true statement. Okay, so let's take this expression right here. 15 is greater than, and where the variable is where you get to plug in various numbers. They're suggesting the numbers that you're going to use for y. So the first time you go to answer yes or no, right there where the y is, you are plugging in a 17. Is 15 greater than? So you have to know how to read this symbol properly. The bigger number is always, or the suggested bigger number, because some of these statements are going to be true, some of them are false. That's why we have yes or no. Yes meaning it's true, no meaning it's false. So they're saying that this is the bigger number. How do you know that they're suggesting this is the bigger number? Because it's sitting inside this open part. The smaller number should be on the other side of the point. The point points right into the smaller number. So this would be a false statement, because the way this is read is 15 is greater than 17, and of course that is not true. Okay, so is it a solution? No. Not true means it's not a solution. And you can put that here as well if you want. Okay, using this statement again, 15 is greater than y, where you're plugging in for the y. 15 is greater than, and what you're plugging in is a 20 for the y value, and that is also not true. So it is not a solution. Okay, moving on to the next problem. 15, this time in place of the y, which is over here on the right side of the inequality symbol, and we're plugging in a 12. 15 is greater than 12. That's actually true. So this means it is a solution. So yes, it is a solution. Let's see, 19. We're going to plug in this last one. 15 is greater than, and this is where we plug in the value they're giving us in the table. Is 15 greater than 19? Because this can only be read one way. The number that's sitting inside the open part is what is considered greater than, or at least that's how you read it. And that these statements are either true or false. So 15 is greater than 19. That is not true. And whenever it's not true, that means it's not a solution. So another kind of problem using inequality symbols. Here below the table, we see another example of an estimated answer. And this says, estimate 5% tip on a bill by first rounding the bill to the nearest $10. So we're going to round this to the nearest $10. Okay, and then you have to know which digit of these 4 digits that you see here, which digit is in the tens place. Rounding to the nearest tens place, and that's why I keep pointing to the one that I am concentrating on, which would be that one right there. Okay, that's the number in the tens position. So that means that you're going to round this to either 70. The next value that would be in the next tens position would be 80. So you're either going to keep it at 70 or round it up to 80. Never round down. Look at the number next to it to make that decision. So this rounds to approximately $70, and we're doing 5% of $70 after rounding it, so that we're not carrying those cumbersome decimals around with us. Again, if you want to do this in your head, let's say it's very handy to be able to figure out what 10% is. So, because you can then double that amount if you want to do a typical 20% tip. If you want to give a little less than that, then you could say, hey, what was 10%? Let me cut that in half, and that'll be the extra 5%. So that's what I'm going to do here. I'm going to talk about it both ways. If you're looking for 10%, think of the decimal being here. Slide it over one place for 10%, and that would give you 7.0, or in other words, $7. So that would be 10%, $7. If you cut $7 in half, half of $7 is $3.50. If you must put it in the calculator, then you would enter it exactly as it reads there on paper. 0.05 times 7, whoops, keep putting it in wrong. 0.05 times 70, 0.05 times 70, and you get 350. So that would be your answer there. Okay, we're attempting to get you to a situation where you can do some of this in your head, but if not, you can use your calculator. Okay, here are some very common terms that you're going to see whenever the discussion concerns less than or greater than. There are very common phrases that we use in the English language. You'll see them when you go into a movie theater. You'll see them when you go to a carnival or a fair. Sometimes you'll step up to a particular ride, and let's say you have your child or your younger brother or your baby sister, and they're wanting to go on that ride, and you get up to the ride and the sign says, height must be at least 42 inches. What does that indicate? Well, if you don't have somewhat of a grasp of less than or greater than, then you don't know if that's greater than or less than 42. But being familiar with your own language, if you have to be at least, okay, so the phrase that we're concentrating on here is at least, and that's what all these examples are down here. Verbal descriptions that contain the phrases at most, or at least, or no more than, no less than, a maximum of, a minimum. These are all phrases that concern less than or greater than. Okay, so this one has at least 42 inches, so we can write it like this as an inequality. The height, I'll put that for H, the height must be at least 42. That means it can be equal to 42 at the bare minimum or greater. They can't let a tiny little person on the ride. That wouldn't be safe. Okay, then this next example, weight. I'll use W for weight. Your weight must be at most, the most you can be, let's say, you're going to get on a piece of equipment and it's going to break if you're over 140 pounds. So you can be at most 140 pounds. So you can be equal to 140 pounds or less than, according to this requirement. Okay, so the phrase at most really means less than or equal to. These are very commonly missed on the test because people start hooking into, oh, it starts with L. Least means less. That is not what it means. People start seeing at most, they think that means more than, and they get that backwards. Very commonly mixed up on the test, and so I threw them here into your notes to go over them. Okay, if the most you can be is 140, that means you can top out at 140 or be less than that to satisfy this requirement. You have to be at least 42 inches. That means the smallest you can be is 42, but being taller than that would be also fine. Okay, this example below, my bank texts me if my balance, we'll use B for balance, is $100 or less. That one's pretty straightforward. Equal to $100 or less. Okay, so we were concentrating on this phrase right here. Next one, GPA must be a minimum of, that's the phrase we're concentrating on there, a minimum of 3.0. Your GPA can be equal to 3.0, but if this is the bare minimum that it can be, then it's okay for it to be higher. The higher you can go with that, the better off you are. Maximum number of allowable errors. We're talking about how many errors. Let's say you're going on a job interview and they give you a skills test and they say maximum number of allowable errors to get this particular job is 4. That means your number of errors that you're allowed to make on the application exam, it can be equal to 4, but it cannot be any greater than that. It can be less than that. The less errors you make, the more desirable you are as an employee. So it could be less than or equal to 4. And I believe that that's all there is. Oh, no. We have comparing and estimating using a graph. So I added these examples on. These are really just examples from your book. Again, if you have an earlier version of the lessons note packet, because I just recently added these, you can just add these on a piece of paper of your own, and you can slip them right into the lessons note packet. Or you can just watch me do these because I don't know that you really even have to copy them down. I'm just exposing them to you in case you see them on the test, but they are not, it's not something that students get really confused about. Okay, so here what you see is a timeline. And all you're doing is giving an estimate. And the good thing with estimate is as long as it's pretty close, you're going to get credit for it. I mean, if it's your estimate is off, then I'm going to know that. But if you're close, that's good enough. Okay, so estimate the year that the microscope was invented. So let's see. Here's the microscope right here. When was it invented? Well, let's check this out. To do an estimate, you have to kind of look and see what is the difference between here and here. So this represents 100, from 1500 to 1600. This is the halfway mark, which would mean, and it's good to know that so that you can make a proper estimate. When you are halfway between 1500 and 1600, in other words, there's a difference of 100, then you're 50 in. So you would be at 1550. Okay, so your estimate better be bigger than 1550 because the mark is right here, almost right on top of the 1600. So let's say we take this 50 right here and split it up into 60, 70, 80. I'm going to say that that looks like a little bit further than 90 even. So let's say this is 60, 70, 80. Let's say 90's right there. I'm going to say about approximately, let's just say approximately 1,590. It's very close to the 1,600. Okay, next one, estimate on this same timeline the year that germs were identified. So let's see, here that is right here. So germs identified as the cause of a disease. Okay, let's see what that looks like. Again, this is the halfway mark, so this would be 1850. It's the halfway mark between 1800 and 1900. And I'm going to say that I'm going to approximate that at approximately 1860. But it would be fine if you said 1859 or 1861 or 1862. But you have to be pretty close. Okay, which happened first? An even easier question. The first test tube baby or the first heart transplant. You're always looking at any kind of timeline or graph that's on the Cartesian plane. In other words, XY system, you're always reading it left to right. Okay, so to answer this question, first thing you hit as you move left to right, let's see, test tube babies, that would be right here. And then we're trying to compare that to first heart transplant. That's this one. Okay, so first heart transplant came before the first test tube baby. So which happened first? The first heart transplant. Okay, bar graph, that would be another place where you're estimating, just like we estimated off of this timeline, this line graph. We can also estimate using bar graphs because sometimes it doesn't hit right on a specific number or a specific line, and so you have to give an answer as close as possible, and that's estimating. So estimate the cost of insurance in California. Well, let's see. I need to know what is happening from here to here. This is 80, this is 100. So if this is, this would be 80, this would be 90, this is 100. So knowing that there's a difference of $20 in here and that this represents 90, then I can give a good estimate when I know what is the difference between the number that it looks like it's almost at and the next number up. So I'm going to say that this would be about 85 right here, halfway up from this point to 90, and this is even lower than that. So I'm going to say that's about 81, 81, 82, something like that. So approximately $81. Estimate the cost of insurance in Arizona. In Arizona, we are super close to 60. So I'm going to say that is approximately either $58 or $59. I'm going to judge in at $59. Okay, so give your own personal estimate and make it close. Okay, scatter plot. That is another place where you could be potentially asked to estimate something. So here it says estimate the minimum wage in 2009. Notice that all of these graphs, otherwise they are unreadable when you're talking about two values that you're comparing, have clear indications, are clearly labeled along the horizontal axis, clearly labeled on the vertical axis so that you can read what you're doing, the answer that you're giving. Likewise, in this particular problem, estimate the minimum wage. This entire table is about minimum wage. You have the year that you're talking about here, and then the minimum wage amount on the vertical axis. So let me try and slide to 2009. That's going to be right before you get to 2010, which would be this point right here, closest to 2010. And the minimum wage If you travel over here, to, line this up with the numbers on the vertical axis, you're just a little bit above 7. Not very straight, but we can live with it. All right, so if this is only $1 difference between 7 and 8, and you're just a hair up from $7, not quite at the halfway mark, so I'm going to say that that is approximately, and some people are going to have different opinions here. I'm going to say that that's approximately $7.25. So just somewhere in that area. We're not all going to give the same answer, but if you are lining up this 2009 properly with the numbers here, then I'll know you're reading the graph correctly. Okay, that is it for section 2.5.